Okay guys, so by popular request I've made a video on negative angles and radians when dealing with cast problems. So let's go straight to it then. I've got this problem, tan theta over 2 equals minus 1 over root 3, going between 0 and 2 pi radians. As normal, principal value theta over 2 equals tan to the minus 1 over root 3 equals, from my special triangles I could know the answer from this, but if we use our calculator and set our calculator to comp mode, so you do that by pressing mode and then option 1 on comp mode. If you go tan to the minus 1 divided by root 3, you get minus pi over 6. So we can use our special triangles, or we could do it the calculator way. Just make sure you've got it in comp mode, because obviously this is an exact answer, and so I shouldn't be having any decimals at this point. So then we've got our check range step. So we don't have theta anymore, we've got theta over 2. So all our theta values need to be divided by 2. We've then got cast. So all silly tomcats, yeah? This negative pi over 6 means in the clockwise direction, so this is pi over 6. And here we're looking at tan is a negative number. So here we know tan is negative, because only cos is positive. And here tan is negative, because only sine is positive. So I can draw my pi over 6 here. I can then say, through solving then, that I have theta over 2 equals, okay, well theta over 2, if I look at my range, only goes between 0 and pi. So it makes sense for me not to choose the clockwise direction, because that's going to give me all negative figures, and then I'm just going to have to plus and minus the period from there. Why don't I take the anti-clockwise selection? This is because once I've drawn this whole diagram, once I've drawn this, then I can use it however I want in any direction. So therefore let's go in the anti-clockwise range. So this means theta has to travel pi minus pi over 6, which gives me 5 pi over 6. And then if I keep going round for the second solution, this is 2 pi minus pi over 6, which is 11 pi over 6. But if I'm looking at my range, this is within 0 and pi, this is greater than pi, so therefore we disregard. So our only solution then is theta equals 10 pi over 6 radians, which is the same as 5 pi radians, or 5 pi over 3 radians. And that one's done. Now let's look at this second one. So here I've got sine 2 theta equals minus 1 over root 2, but going between minus 2 pi and 2 pi. So again, PV 2 theta equals sine to the minus 1 over root 2. Could use our special triangles again, couldn't we? But I'll use my calculator. Sine to the minus 1, make sure it's in radians, 1 over root 2. This gives me minus pi over 4. If I check my range, I don't have theta anymore, I have 2 theta, so this is 4 pi radians going to 4 pi radians, so minus 4 pi to 4 pi. Then we then do cast all silly tomcats, yeah? So we're looking at this negative principal value here, so this is pi over 4. And where else is sine negative? So sine is negative in cos, but it's also negative in tan, so this pi over 4 must go here, yeah? Pi over 4 radians. So this is going in a clockwise fashion, isn't it? And because my range goes between negative 4 pi and 4 pi, I can continue down this clockwise route. So I can say, if I solve, I get 2 theta equals, going clockwise, minus pi over 4, that's our first solution. And then this one here is pi, well, minus pi plus pi over 4. So this gives me minus 3 pi over 4. So that's solution number 2. So again, as always, if I take my first solution, then add on plus and minus the period. So the period is 2 pi in sine. So that would be 8 pi over 4. So if I minus 8 pi over 4 to this first one, I get minus 9 pi over 4, which is in range. I'll minus the 8 pi over 4 again, so that's minus 17 pi over 4. Is that in range? No, because 16 over 4 is 4, so therefore 17 over 4 is too small, disregard. So let's do it the other way. So start with my minus pi over 4 again, but do positive this way. So plus 8 pi over 4. So I get 7 pi over 4. Do it again, I get 15 pi over 4. And if I did it again, it would be too big, it would be out of our range. So let's do solution number 2. So minus 3 pi over 4 minus 8 pi over 4, that gives me minus 11 pi over 4. If I did it again, it would be out of range. So I go the other way, minus 3 pi over 4 plus 8 pi over 4, I get 5 pi over 4. Do it again, 13 pi over 4. If I did it again, out of range. So the final solution, or solutions, is theta equals minus pi over 8, minus 3 pi over 8, minus 9 pi over 8, 7 pi over 8, 15 pi over 8, minus 11 pi over 8, and 13 pi over 8. So a lot of solutions. These are all in radians, so we need a little c in there. Okay, that's that one done. Finally then, we've got this problem here. I know this is not going to give me an exact figure. It's going to be in decimals, so it's not going to be in terms of pi, because I've got this, what will become tan x plus 0.9 radians. Let's change that to an x to keep it consistent. Equals minus 1 over 2, because remember I can't have anything next to my tan, cos or sines. So therefore I get what I had earlier by doing my PV. So I get x plus 0.9c equals tan to the minus 1 minus a half, whack that in the calculator, tan to the minus 1 minus 0.5 gives me minus 0.4636 radians, because remember we worked to 4 significant figures, then we round to 3 at the end. Okay, so my range, I don't have theta, I don't have x anymore, sorry, I have x plus 0.9 radians, so I have minus pi plus 0.9 radians, x plus 0.9 radians, pi plus 0.9 radians. Yeah? Now what's a good tip for you is if I've got stuff in decimals, I think it's a good idea to write out this stuff in decimals as well, so you can really clearly see your range. So if we do minus pi plus 0.9 radians, that gives me minus 2.24159 blah 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 radians. X plus 0.9 radians, and then pi plus 0.9 gives me 4.04159 radians. Dot, 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 dot. Yeah, it just gives me a rough indication of what I'm looking at here. So, cast all silly tomcats, yeah? My principal value is minus 0.4636, so this is going to be 0.436, sorry, 4636. We're looking at tan being negative, so tan is also negative in the sine quadrant, so 0.4636. Now solve. So I've got x plus 0.9 radians equals, if you go in this clockwise direction as we started with, we get minus 0.4636 as our first solution, and our second solution is minus pi minus 0.4636, which gives me minus 3.605. But this is too small. It's not in our range, so I disregard. But I've got to keep this in mind for adding a minus in the period, okay? So if we go from our number 1, our solution 1, if I subtract the period of pi, I get minus 6.7467, blah, blah, blah. Too small. If I do my minus 0.4636, because remember we're looking at tan, plus our period of pi, I get 2.678 radians. And if I plus pi again, I get 5.8195, which is too big. And if I did the same to the second solution, minus 3.605 plus pi, I get minus 0.4636, which is the same as what I started with. And if I keep doing that, you'll see that I get the same as what I started with. Okay, so the only two solutions that fit in our range is this and this. So therefore I get x equals, we're just minusing 0.9 from either side, so minus 0.4636 minus 0.9 gives me minus 1.3636 radians, which will be 1.36, because remember we're doing it to 3 significant figures. And then if we do that the same to solution number 2, so 2.678 radians minus 0.9 gives me 1.78 radians to 3 significant figures. And they're the only ones that are inside our range. So that's it, that's solved.